Hello, friends and followers. So here's the National NC300 I'm working on now. And there's this interesting little stabilizer you can see here on V13. That was some type of resistive element that was supposed to stabilize the current. The whole thing was, way back in 1955, your line current going into your house might change. I know when I was growing up, our line current changed a lot because the fuse box was not correct. Anyway, so this thing tends to get replaced by all sorts of gadgets and ideas. And here's the V7. I think this is a 6AH6 or something. This is the oscillator for the radio, the heater. So I guess the whole worry was, if this heater changes output, it will change the oscillator's frequency. I don't know how true that is, but they certainly believed this way back in the day. So anyway, the owner of this radio previously had put in a circuit to run the tube on 12 volts. I think he was using a Xenia or something, I'm not sure. But anyway, what I finally did was just simply use the diode that he was using. So this wire on pin 7 here comes off of 12 volt tap, and they even have their own tap on the transformer. So if you look at the transformer, yeah, it has this tap, 13.5 volts, which isn't even connected to anything else. That's how critical this was. So that resistor's gone, and on pin 7 that wire comes in from the transformer, 13 volts on its own circuit. So I just had that going to a diode that the guy had in here. So the gentleman had his diode in here, and he had this capacitor, which seemed okay, 1000 UF capacitor at 50 volts. So I get about 16 volts of headroom on this little unregulated DC supply, which is pretty cool. So if we check the supply here, then okay, there's 17 volts or so. At any rate, you want to keep the tube at like 6 volts. So I found that one of these, what are these called? 7806s. One of these 7806s weren't enough for the current of the tube, and I was getting about 5.5 volts. These should regulate at 6 volts. So here's the input here, which, as we know, is raw 17 volts DC. Here's the output. And the output now is pretty much 6 volts. And the cool part is, if I vary the line current now, that won't budge. So that's the intent of what the national designers wanted, was that the filament voltage to that oscillator wouldn't vary. So these are getting warm, they're not getting hot. And I have these things thermally grounded to the case with solder, so they are really going to be dissipating some heat. Okay, so I'm just looking for a jumper. I want to show you guys the voltage stability now. So let's just hook this onto here and hook this onto here without causing a short circuit. Damn it. Okay, now that's the voltage that is going into the heater of that tube. And now we're on the variac. Whoa, this thing's cranked way too high. Any rate, if I vary this variac like this, between 100 volts and say 120, this thing doesn't budge at all. It just stays steady. That's what you want. So I'm really happy with how that turned out. I can really take this thing down to there's about 90 volts. it's maintaining. Go up to high voltage 128. It maintains. So that's what I wanted. And I'm happy with that. So that's the story on the 5-volt circuit here. And so in the literature from years of playing with these 7806 and 0805 devices, they always said, don't parallel these, they won't work, and you know, all that crap in the engineering notes. And I just said, what the hell, you know, this is an old radio. This is an experiment, so I simply paralleled these two, and it works like the bomb. So I'm not sure how long it'll work like this, if it'll short out. If it does short out, the tube will vaporize, the heater will vaporize at 17 volts. But anyway, they're holding for now, so live and learn. I like the heater right smack at 6 volts. That's, I guess they're supposed to run at 6.3 volts, but who's counting? It's very stable, a stable situation now. In fact, I can show you how stable it is here. We'll just go like this. There's the voltage. There's the variac. Here's the pointer right here. Check that out. It's damn stable if you ask me. Doesn't move, it doesn't budge. So that's better than even National did way back in the day. I don't know how critical that is, but they thought it was important. So anyway, we'll see if it affects the stability. All right, that's about it. I also fixed the antenna trimmer. It was all screwed up. This thing was all beat up and smashed. The pins are all bent, so I had to spend time on bending this thing and ohming it out. It now goes, I had to solder it too, right there. One of the fins was broken off, so I think now it runs okay without a short. It'll turn without shorting. I just don't want to even have it near the radio until I'm ready to put it back in and not jostle things around. I didn't bend it up, the previous owner did. Anyway, that's what's going on now. I still got to lower the B plus here down to like 150 volts. It's way too high. They use a 330 ohm resistor here. I'm thinking if I put a 500, before that resistor, if I put a 500 right here off the diodes to the capacitor, 500 ohm resistor, that would work. I could just solder in a terminal strip there and do it, and just do it like that. So yeah, I don't like hacking parts in the radio, but I think in this case, they're useful. All right, so that's my little story. Thanks for watching. Yeah, this thing does fire up. It should be playing right now, I would think. It's turned on. All the wires, I think I borrowed a wire for the speaker or something. Anyway, it does indeed play. I just gotta get the speaker connected back up to it. Okay, thanks for watching. Have a great day.